So for this lesson today, we are going to go over some basic safety and hazard prevention in the field of HVAC. One thing is we have to always remember is when we are on a job site, service call, doing a repair, whatever it is that we're doing in HVAC, we have to really make sure that we are doing it in a safe and conscious manner. We deal with a lot of different types of chemicals. We deal with electricity, we deal with refrigerants, we deal with gas, we deal with oil, we deal with combustion. So we are a trade that really kind of just covers a real vast amount of area. And we're going to see and deal with a lot of different elements in situations that can honestly put us in harm's way if we're not safe, and other people that we're working around. So with safety, obviously we're going to deal with a lot of electrical components. Okay, we're going to deal with contactors, capacitors. We're going to be dealing with relays, fan centers, circuit boards, fan motors. We're going to have to be on our guard to try and prevent, obviously, getting shocked. Okay, we don't want to get shocked by electricity. It can hurt. Okay, it is really the current in electricity that is really the factor that can honestly kill us as a mechanic or hell, even anybody. Okay, you got to be vigilant. As I always tell everybody that is in the HVAC trade or has ever worked with me, that's like an apprentice or even just like an entry-level mechanic who just got his license, I always say the same thing. Take a step back. Look at the entire picture. Look for obvious signs of problems before you start getting into a piece of equipment and start digging into the wires and so on and so forth. Just look at the basic picture. Look at that wiring diagram. Is my wiring correct? Because if the wiring isn't correct and I go and turn that on, I can create a short. I can create a spark. I can even create an explosion if I'm not careful. And if I'm a part of that circuit, if one of those things happen to happen, I'm going to get shocked, and I don't want that. So you take that time, take the extra 30 seconds, a minute or so, just to look it over. See what you're dealing with. Okay, current, anywhere between 100 and 200 milliamps is going to generally cause your heart to fibrillate. It's going to make your heart go absolutely crazy. Okay, our hearts are obviously a very delicate component in our body. We all know it. It keeps us alive. Our heart is not meant to get any sort of electrical charge outside of whatever our body is meant to do. That fibrillation in our heart, even though it's 100 to 200 milliamps, 1/1,000,000th of an amp, that can do some serious damage to us. Okay? 110 volt power circuit, okay, will generally cause about 100 to 200 milliamps of current flow through the body in most of us. Okay, so your simple outlets in your home is about 115, 120 volts, right? So there you go. You can probably, that's why mom and dad always used to tell you, don't stick anything inside the light socket when you were a kid. It's because you can get shocked. Most of your residential HVAC equipment is going to operate off of 115, 120 volts. You can get shocked if you are not careful. So one way we use this to protect ourselves from getting shocked, especially if we're on a job site or we're working with multiple people, is we use that lockout tagout procedure. Okay, it's whenever we are using or working on a piece of equipment, we should always disconnect the power from that unit. Shut off the service switch. Shut off the breaker. If you're working on an air conditioning condensing unit, make sure you shut off the disconnect that's outside. Okay? And tag it. Lock it out. Letting other people know that you are working on this piece of equipment so that they're not the one to go and plug it back in or turn it on or energize the power source again while you're still working on it. Communication in a lot of ways is very, very important in HVAC. You have to let other people know what you're doing. Okay, so one way we use that to communicate is we use the lockout tagout procedure. Usually the lockout tagout procedure is you come with a little lock, and you're the only one with the key to that lock, and it will come with a little tag as you see here. And it will usually say danger, just like you see. Okay, equipment is locked out by, and you're going to put your name, and usually on another line is going to give you a line to tell you what you are doing to that piece of equipment. Changing your gas valve. Units locked out by me because I'm changing a gas valve. Units locked out by me because I'm changing a compressor. And you're going to date it. Once that unit is locked out and you have the key in your hand to unlock that lock, you're good to go because nobody else can remove that lock but you. If you don't have a lockout tagout kit, you can use your own separate padlock if you have one. I have in the past, I've used tie straps and put a tag on them myself, a handwritten tag, and just tied it through the disconnect or on the breaker or something like that. Something to identify the fact that this breaker is off or this disconnect is off for a reason. Okay? So you got to make sure that you're communicating and doing things correctly. Because if you're not, you're going to get hurt. Okay? They say in a lot of cases never want to work alone when you are working with live electrical circuits. Well, unfortunately, in the service aspect of HVAC, you're probably going to be working alone on a lot of jobs and a lot of service calls. Not unless that service call requires another mechanic to be with you or an apprentice or something like that. But probably I want to say about a good 85, maybe 90% of the time, you're going to be working alone when you're doing a lot of service work. In construction and install work, yeah, you're going to have a crew. You're going to have maybe 2-3 guys on a job site with you. So again, you're going to have to make sure that you're communicating and having that teamwork so that you can be efficient and get the job done without anybody getting hurt. Okay. It's always good to know or have somebody on your crew that is actually CPR certified, because you know what, you never know. Accidents do happen. People mess up and get hurt. So sometimes it is very good to have that training just in case someone does get hurt and you're really the only person that's actually on the site that's actually capable of maybe saving that person's life. When you are doing a lot of stuff, it's always good to have a first aid kit on your truck, and again, learn CPR. Know what to do in the event of a emergency. with a person that may be getting electrocuted, or maybe has suffered a shock, or has maybe fallen off a ladder. It's always good to have some additional training like that, so you know what you should and should not do. Not only to maybe save that person's life, but to also obviously protect yourself from becoming a part of that problem. We don't really ever want to wear any sort of rings or jewelry when we're looking on electrical circuits, because they are conductive material. If we are getting shocked, we can get an electrical burn. Yeah, it's a conductive material. We don't want to do stupid things with the power on, like putting screwdrivers inside electrical panels, or throwing a screwdriver inside a disconnect, or a switch with the power on. Okay, anything that's conductive, we want to try to refrain. We want to be able to use it correctly. When you're using portable tools, portable electrical tools, okay, your electrical tools are constructed of a metal frame and have a safety ground wire and the power cord. If you are using an old-fashioned electrical drill or something like that, and it only has the 2 prongs, you should be going to Home Depot and buying the adapter, the 2-prong to 3-prong adapter. The things are probably maybe $1 something, maybe $1.50. Pick up one. Keep it in your truck, keep it in your tool bag, whatever that you're dealing with, and use that adapter to that piece of equipment. When you are using those types of adapters, one thing that you need to really make sure of is that the adapter is actually properly grounded. Okay, when you see them, they're either going to have the 3 prongs coming out of it, or you're going to have a 2-prong with a little green wire sticking out one end of it. The green wire is the ground. That green wire should be connected to that electrical outlet so that you actually ground that piece of equipment in the event that something is to go wrong with that drill or piece of equipment that you're dealing with. Okay, more modern handheld tools are constructed of plastic and are usually double insulated, so they have taken a lot more precautions when it comes to power tools and things. But still, you still want to make sure that you are taking the necessary precautions. You want to use non-conducting ladders in the field. Okay, fiberglass extension ladders, fiberglass step ladders are really the best type of ladders that you should have and should be using. Wood ladders, absolutely not. Okay, even though the PowerPoint here says so, I do not agree with it, because wood rots after a while, especially if it's in the elements over a long period of time. It rots, and that's just another accident waiting to happen, especially if you got some big old guy trying to get up on that ladder and the thing snaps in half. Okay, fiberglass is your type of ladder that is really non-conductive. Aluminum ladders, if they become in contact with your power lines, it's an accident waiting to happen. You're going to get shocked. Okay, now in HVAC, we all know we're going to be on extension ladders. You're going to be on 8-foot ladders, 6-foot ladders, step stools, all sorts of stuff. So you want to make sure that you are doing your work safely with minimal risk to yourself. We're also going to be dealing with a lot of pressure vessels in our field. Piping, compressors, propane tanks, okay, to name a few. Refrigerant cylinders. All of those are pressure vessels. Okay? The pressure in a vessel is always going to increase as the temperature in the vessel increases. Remember, in HVAC, one golden rule that we should always remember is that the higher the temperature, the higher the pressure. If a cylinder gets to a high enough pressure, it can burst, and that is going to be a potential danger. Okay, refrigerant cylinders is a prime example of that. They're stored. When we're dealing with any sort of pressure vessel, any sort of cylinder that is carrying some sort of gas, it should be stored in an upright position. It should be stored so that it doesn't fall on us. It doesn't roll around in the back of our truck, but it should be secured. If we are moving large cylinders, they should be moved only when that protective cap is in place. For example, a nitrogen cylinder. The nitrogen cylinder, that protective cap should be on anytime you are going to move it from point A to point B. Because what happens if you slip? What happens if you fall down a set of stairs? Because, hey, you lose your balance, right? We're only human. If we don't have that protective cap on there, we can actually create a very dangerous situation. Okay? Large cylinders should be secured on carts that are designed to move those cylinders if you have one. Preferably a hand truck. That's another great tool to have at your disposal. A hand truck that you can move these types of cylinders from back and forth, from your van to wherever it is that you're working. You should always be wearing your personal protective equipment, safety glasses and eye protection. Wear gloves if you're dealing with refrigerant so that you don't get frostbite. Whatever personal protective equipment that your company wants you to wear when you're doing certain jobs, you should be wearing. You should always take precautions to prevent the tanks from falling over, because if that stem falls off, that cylinder, it's going to become a projectile. It's going to become a missile. Okay, your standard large nitrogen cylinders can have about 2,500 psi inside them. So if that stem happens to break off, that nitrogen cylinder, it's going to release about 2,500 psi in full force, and that cylinder is going to become a missile. I know Mythbusters did an episode on a nitrogen cylinder where they actually broke the head off of it, and it went through 2 cinder block walls. So they are very dangerous if we are not careful with them. Okay, a lot of electrical hazards that we're going to have to. We have to exercise caution when working on or around electrical circuits. Again, look at the big picture. Look at any exposed wires. Look for any loose connections. Look for any wires that may be frayed or touching maybe a metal cabinet or shorting out somewhere, because those are all electrical hazards that we need to be addressing when we're dealing with and working on HVAC equipment. Okay, uncontrolled electrical current flow can result in an electrical shock or burn, depending on that voltage. Always follow your lockout and tagout procedures. Exercise caution when working on live circuits, and do not come in contact with any sort of energized conductors. If you are not sure if the wire or unit is live or disconnected, you have that wonderful tool in your tool bag, and that's called the electrical meter. Use the electrical meter to see whether or not you have power or not, and then make the necessary changes. Find that breaker, find that other electrical switch that may be controlling that piece of equipment and shut it off and tag it out. Okay, so electrical shock, it's going to happen when that person becomes a part of the circuit. The severity of the shock is determined by the voltage, current, and the amount of current that it takes it to flow through the body. Okay, current flow through the heart can be fatal. And to help prevent electrical shock, always wear insulated boots and do not stand in water while working on equipment. Okay, you should also be checking for grounds. Make sure your units are grounded. Ground wires. Okay, the ground wires is what protects and provides protection from electrical shock. The ground wire provides an alternative path for that current to take. Remember, electricity is always going to follow the path of least resistance. That path of least resistance is going to be either through a ground wire or through you. Hopefully, it's going to take the ground wire and not you. But that's why you need to take those precautions to make sure that you do not become a part of that circuit. All of your tools should be properly grounded. All of your power tools should be properly grounded. Okay? Do not use tools that have damaged or missing ground prongs. Okay? That's just being stupid. Okay? Ungrounded power tools have two prongs to them. One supplies your voltage to the tool, the other is your neutral. Okay? If the tool becomes grounded, current can flow through the tool and through the user to ground, causing an electrical shock. Grounded tools are going to have your three prongs. One's going to be your power, the other one's your neutral, the other one is your ground. If the tool becomes grounded, the current will flow to ground through the ground prong, protecting that user. So, grounding is very, very important. If wall outlets have only two connections and the tool has three prongs, you have to use the adapter, as I previously stated. Plastic case tools are double insulated and often have only two prongs. Battery operated power tools are convenient and obviously safer. Okay, ground fault circuit protectors, or GFCIs, sense small electrical leaks to ground. Per a lot of electrical code, your ground fault circuit interrupters need to be installed in your bathrooms and in your kitchens, anywhere there's close to a water source. There's obviously a reason for that. Avoid wearing metallic jewelry while working on electrical circuits because they conduct electricity. Never use screwdrivers in an electrical panel when the power is on. Burns can result. Pardon me. If the screwdriver slips and makes contact between a hot terminal and ground, you're going to get shocked. Okay? That's why we don't want to use any sort of screwdrivers inside any sort of electrical panels. Always use non-conducting ladders. Fiberglass ladders are preferred. Ladders should be placed on level surfaces. Damaged ladders should not be used. Ladders should be free of oil, grease, and other slipping hazards. Okay? It's always good to inspect that sort of stuff. Ladders should have slip-resistant feet. Secure the ladder in place whenever possible. I disagree with that, whenever possible. If you are using an extension ladder, that extension ladder needs to be extended 3 feet above the roof line and tied off to something. OSHA does make surprise visits to job sites. If they see that ladders are not properly secured or properly extended like they're supposed to be, that's a violation. OSHA can shut the job sites down based off of unsafe work habits. So ladders need to be properly used. Okay? Ladders should not be used as scaffolding. Ladders shouldn't be used for you to use as an extension to get you up any higher. If you're using a 6-foot ladder to try to reach something that's 10 feet up in the air, you're doing it wrong. Get a 10-foot ladder and put it and use it. If you're trying to do work on the side of a building that's 30 feet high and you're only using a 24-foot extension ladder, it's not going to reach where you need to be. Get the correct ladder size and use it correctly. Heat-related issues, well, we're in HVAC. We're going to be out in the cold, the wind, the rain, the snow, the sleet. We're going to be out there in the dead of summer in the heat and humidity in 120, 130 degree attics. So we need to make sure that we are also taking precautions to protect our body from hypothermia and obviously heat stroke. And we're also going to be doing a lot of soldering, brazing, doing some hot work. Okay, so we have to make sure that we don't burn someone's house down or someone's building down. So we must make sure that we take our torches and concentrate that heat to where we want it to be. Keep torches away from any sort of combustible material. I think that's a little common sense. It's always good to have a fire extinguisher nearby when you're doing any sort of soldering or brazing in someone's attic or maybe even someone's basement or in anywhere. Okay, so you should also use a fire shield when soldering near combustibles. Sometimes you're going to have to do some work where there is a combustible cylinder or something that's close by. So you're going to have to figure out a way to contain that flame and that heat so that you don't obviously create an explosion or do something stupid. Okay, hot pipes and motors obviously can cause burns. So we want to make sure that we're careful and we know what we're working on. Working outdoors and in hot attics obviously can also cause injury. Okay, the cold can be just as dangerous as being in the heat. Okay, liquid refrigerant can cause frostbite. Okay, in fact, an R22 refrigerant is going to boil at negative 41 degrees at atmospheric pressure. Wear warm clothing and waterproof boots when you're working in the cold and wet environments. And cold weather gear should be worn when working in low temperature freezers. Okay, rotating machinery can cause injury. Loose fitting clothing can be caught in your motors or any sort of rotating devices such as your fans and belts and pulleys. Never try to stop a rotating machine by hand. Your jewelry can get caught in that machinery, especially if you're bending over. Okay, always use eye protection when working on or around any sort of rotating machinery because those fans can kick up debris that might be sitting inside the fan wheel or inside the unit, so you don't want to get it in your eyes. And never, ever, ever, ever try to stop rotating machinery by hand because you will lose your fingers. Okay, so you be careful. When you are moving objects, the safest way to move an object is either with a hand truck, a dolly. Okay, never lift with your legs. Lift with your legs, but not with your back, because obviously that's going to cause injury. Refrigerants in a breathing space. If we are dealing with a air conditioner or a freezer or something that's dealing with refrigerant gas is heavier than air. These gases will displace oxygen. Okay, so you want to avoid breathing refrigerant vapors. Okay, always use proper ventilation and use special leak detectors and alarms. Okay, those are going to be required on some of your applications. Okay, we also use soap bubbles. We use electronic leak detectors to locate and pinpoint where leaks are. Okay, ASHRAE Standard 34-1992 addresses your refrigerant toxicity and flammability. We are also going to be dealing with chemicals. We deal with chemical cleaners to clean our condensers and evaporator coils and other pieces of equipment. Okay? We use water treatment solutions. Those all should be handled in accordance with manufacturer's directions, and always follow your manufacturer's first aid procedures if it does come in contact with your skin or in your eyes. Some of this stuff can cause irritation to your eyes, throat, and skin, so obviously be very, very careful.